It's not just genomic data, Ronen. A person's health is influenced by much more than that. The environment in which the person lives, nutrition, drugs the person takes, immunizations, infections, and whatnot.
Well, I don't know what not, but probably there's an app for that.
You mean the EMR, the electronic medical record that we have in clinical settings? That's tons of mess, which is completely unorganized.
Indeed, clinical EMR systems have tons of individualized genomic and non-genomic data, and it is a mess. But with the right kind of machine learning tools that make sense out of this mess, this data can become a goldmine. And there are also new kinds of sources of data. When I said there's an app for that, just think about all those smartphone apps that let you, if you are a patient or not a patient, self-report various kinds of medical and health-related issues.
But people find it quite hard to type in information, medical information about themselves.
People in need actually do that. Some of these apps became very popular. The developers have invested a lot in creating really engaging experiences. But today there are also smartwatches and other dedicated medical wearables. They can detect automatically 24/7 things like all your motions, heart activity, ECG, blood pressure, insulin and glucose levels, your sleep quality, even your urine, and soon probably also...
These data resolutions are more than we ever had in the past, and the potential is quite amazing. But still, it can't capture the entire scope of medical information that we're now collecting in clinical settings using specialized equipment.
In order to explain this technology, one needs to understand the scientific context. The big picture here is putting diversified types of data into use automatically. And machine learning achieves that. For example, an unmet need in medicine is early detection. Now, if the goal is to detect patterns that raise a red flag, it's similar to what happens with your car when suddenly it makes strange noises and you take it to the garage where they inspect it with much more dedicated equipment. And there are other applications for diagnosis, prognosis, predicting of treatment outcome and more.
A bit futuristic perhaps, but this technology has the potential to challenge our current paradigms for classifying diseases and patients. It might identify new, novel categorizations based on parameters that we didn't even think of looking at in the past. As a physician, to me this is a bit counterintuitive. We usually look for mechanistic understanding, not just empiric correlations. But hey, this could be a first step towards mechanistic understanding, right?
Exactly. With machine learning and big data, many times you don't need a mechanistic explanation. Let me explain with an analogy from the digital revolution. The algorithm behind the famous phrase, customers who bought this item also bought that. It accounts for around 35% of Amazon's revenues, and of course many other purchases and clicks all over the internet. People find it magically useful, and it does make sense why it matches people's taste. The machine learning just works without really inferring each individual user's properties or an item properties.
Speaking of big data and machine learning, it reminds me of a paper I read in Nature Biotechnology, in which machine learning analyzed big data from ALS patients who used the self-reporting app like the ones you mentioned in the beginning of this session. And actually in this example, the results were aligned with the results of a double-blind, randomized, controlled clinical trial, but took much less time and at very low cost.
I actually know this paper. Me?
You?
I, with all modesty, can give a fantastic explanation on machine learning interpreting EMR data and also that paper.
You will. Okay, and I'll come back for another Spotlight session next week.